All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. As always, we have a great event on tap. I'm really excited to hear this conversation that our speakers are going to be having today. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the conversation, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's conversation you have a question for either of our speakers, please don't wait, don't hesitate. Just use that question and answer tab right there on your interface and submit your questions. And we will actually be answering the questions throughout the webinar, and we'll also have a dedicated question and answer period near the end of today's webinar. We also have one polling question that we're going to be asking to kick off today's conversation, and we have a handout in the handout section. So it's free for you guys. Just go ahead and click on that. You can download it at any time during today's webinar. Please do so before the end of the webinar, though, because I'm not sure how you're going to be able to access it later on. And then finally, we are doing a drawing for 4 $25 Amazon gift cards at the end of today's webinar, so please stick around. Hopefully you'll be one of our 4 lucky winners. Also want to let you guys know about a very interactive chat feature that we have here on the interface. We have the public chat, and I will be on the front end just chatting you up, seeing how everybody's doing today. But I do encourage you to chat us your questions, comments, suggestions, whatever you got for us. Just send it along, and maybe we'll incorporate it into the conversation. All right, with that, let's go ahead and kick off today's webinar, which is Infrastructure as Code, the Good, the Bad, and the Ugly. Our speakers today are Ohad Maislish, who is the CEO and co-founder of NV0, and Tim Davis, who is the DevOps advocate at NV0. That's hard to say. I'm sorry, guys. It's NV0. But welcome to you both for being here. And I am going to kick off today's conversation with a polling question, as I said. Then once I do that, I'm going to take myself off camera, put myself on mute, and let you guys get right to your conversation. But first, let's go ahead and kick off that polling question. The poll should be up on your screen if you don't see it now. It is right there in the polling tab under Open. The question is, do you use any infrastructure as code frameworks? And you can choose from I use Terraform, I use CloudFormation, I use ARM, I use Pulumi, I use another framework, or I do not use any infrastructure as code. So guys, I'm going to go ahead and leave this polling question open for a minute or two and let the audience make their selection. But I am going to take myself off camera, put myself on mute, so you guys can go ahead and start your conversation. When you're ready, we'll revisit the polling results.
Excellent. Thank you so much, Charlene. As she mentioned, I am Tim Davis. I'm the DevOps advocate with M0, and I am joined by our CEO and co-founder, Ohad, here. And we're going to skip all of the, boring slides and stuff like that today. And we're just going to have a conversation. We're going to talk about infrastructure as code, some of the types of frameworks, why you might choose one over the other. We're going to talk about some of the pitfalls of infrastructure as code that you might run into, how to mitigate some of those. Also, some specific use cases for infrastructure as code. So we've got a lot going on here. Please feel free to answer, or not answer. Feel free to ask any questions that you would like, and we'll go through and answer those. I've got the poll pulled up on the side here, and it looks like we have quite a few that are using Terraform so far. So we'll kind of talk in that direction. I see some other ones here, and I use another framework. If you do that, feel free to post in the chat what framework that is, because we're always interested to see what people are using. And then we have a bunch of people that don't use any infrastructure as code framework. So maybe this will help you out and kind of ask the right questions to get started. So, just to get kicked off a little bit more about us, Ohad, why are you qualified to have this conversation? What's a little bit of your background and kind of why you're driven towards infrastructure as code?
Wow. So first of all, Tim, it's great talking with you again. We really enjoy spending time together. Regarding myself, my background is technical. I was an engineer, then a manager, and in the last few years, I became an entrepreneur. And it's really obvious that the cloud is shifting from manual clicks of some GUI in AWS, GCP, Azure, and others to code. So the cloud is no longer just cloud resources; it's a combination of cloud resources and some Git repo in your GitHub, GitLab, Bitbucket that contains infrastructure as code, like Terraform, and that's like the new way to operate cloud. We spent in the last 2.5 years maybe 1,000 customer and potential customer conversations, and it's really great to see the shift from manual operation to code, infrastructure as code, workflows of the cloud, and it's fascinating to see how this affects so many things in companies.
Yeah, for sure. And these days, it seems like everything is, turning towards the code direction. We're seeing infrastructure as code, security as code, policy as code, all kinds of different things. Today, we are going to focus on infrastructure as code. And I mean, Ohad, you kind of answered, one of the main questions there of what is infrastructure as code? And it is the new evolution of building infrastructure. You're not going around and clicking around and saying, I want this kind of instance or I want this kind of, database. You're building out a code file that says this is exactly what it should look like, and you're processing that for your deployment. So, a little bit of my background, I am currently the DevOps advocate. Technical content, community engagement and things like that. But my background is in infrastructure. I like to make the joke that I bring the ops to DevOps because I don't have a heavy development background. But really, in all of my time of working as a systems engineer, systems administrator, going through, I also changed into architecture. I've always been focused on the application because really there's no point in delivering infrastructure just for the sake of infrastructure. You're delivering it so that it can run the application that runs the business. So that's kind of my natural focus and kind of pushed me towards the DevOps direction of bringing development and operations together and kind of helping bridge that gap. And that's really what I do these days. So let's jump right into it. So we kind of talked a little bit about what infrastructure as code was and all that. So let's talk about some of the frameworks. Let's kind of break this down. Infrastructure as code is a really broad category of a bunch of different types of things. Infrastructure as code, there are a few different types. There are declarative, where you specifically say, this is what I want it to look like in the end, and then it just goes out and build it for you. Or there's imperative, where it's kind of like a script where it processes, A, B, C, and D down the line until it's done. But with that, there's a bunch of different types of frameworks. Now, all of these different frameworks can be broken down into either a cloud-specific framework or a cloud-agnostic framework. Ohad, in your experience, what's kind of some of the either pros and cons, or why would you pick a cloud-agnostic over a cloud-specific, or vice versa?
That's a great question. From what we've seen, we see a big shift from the cloud-specific, mainly CloudFormation and ARM, to the multi-cloud, maybe not agnostic, it's multi-cloud. It supports more than one cloud, but in a different way, like Terraform and Pulumi. And companies themselves often use more than one cloud. And also those frameworks like Terraform and Pulumi, the multi-cloud, tend to be more open source. Then with the power of the community, you have like a large ecosystem of other things that you can use. First of all, support. If you have something that you want to ask, or you're not sure, or even you want to change, okay, you can practically do a pull request and push towards something being modified. So I think when we started Env0 a few years ago, we saw more CloudFormation and ARM than we're seeing today. Today we see more Terraform, we see more Pulumi. By the way, that's exactly what the poll here says, that a lot of people here say that they use Terraform, and that looks like the de facto standard, at least nowadays, of how to do infrastructure as code. And this has also other integrations with other standards for policy as code, like Open Policy Agent, and for cost prediction, like InfraCost. All of those work really well with Terraform, because when it's open source, it can really integrate well with other open sources.
I agree entirely. And I mean, obviously, Terraform is kind of the de facto industry standard, as you said there. It's got the most support. It's got the most modules. So many people are using. I am seeing, people talk more and more about Pulumi these days, just because you don't have to learn a different language and stuff like that. It's a little easier to work with for some people based on however they're trying to use it. But you touched on a piece there where if you're going not necessarily cloud agnostic, but a multi-cloud framework, it gives you a lot more support. It gives you a lot bigger community, gives you a lot more extensibility. I know Terraform doesn't just do, the big three cloud providers. It does a ton of different things. There's also some SaaS platforms, and there's actually some hardware. I know F5 has a Terraform module so that you can, automate some of the stuff inside of their physical hardware. So you really can do a lot more with
NF0 has its own Terraform provider. Instead of clicking button
right.
NF0, you can do it with a Terraform provider.
There's so much you can do with it, as opposed to, say, just a cloud formation where all you can do is automate AWS stuff. For that, it'll actually help you out by choosing those frameworks for portability later. You may be 100% AWS now, but down the line, you may not be. You may, acquire a company who is somewhere else. So it's just one of those things where, making that decision beforehand, and we're going to jump forward a tiny bit because one of the things we're going to be talking about is some pitfalls. And one of the biggest ones is choosing the correct framework from the beginning. And this is just one of those things where if you're 100% in AWS, CloudFormation may work for you, but your long-term strategy from supportability and even portability, if you have to, move your workloads and stuff later, if you are using a Terraform or a Pulumi or one of those multi-cloud frameworks, it may be a little better for you to do that. So, what are some other, multi-cloud specific frameworks that somebody might have heard of or be playing with or run into these days?
In addition to Terraform and Pulumi, and there are a bunch of others, but again, the main two are Terraform and Pulumi. And as you've mentioned, we see people choose Pulumi because they feel it's easier for them to do the first steps. They don't need to learn a new language, which is a great advantage. People often don't like that much HCL, which is the base technology or format behind Terraform. It's HashiCorp configuration language. So people prefer to use a syntax that they're more familiar with. But honestly, today, as we clearly see in our polls, Terraform is the clear, de facto standard. Pulumi might be the second one. By the way, also important to mention TerraGrant. It's
that's what I was looking for.
We sometimes say TerraGrant. It's like the cousin of Terraform. You cannot use TerraGrant without Terraform, but it's like an extension of Terraform to do more things. By the way, I have to say that NF0 supports both Terraform and TerraGrant. So if you use both Terraform and TerraGrant, I think it makes a lot of sense for you to check out NF0. And TerraGrant has some features that Terraform doesn't have. By the way, TerraGrant used to have many more features that Terraform didn't have, but with each new version, Terraform closes that gap. But we still see people use the TerraGrant, apply all or run all for some workflows and dependencies between Terraform workspaces, which is a very interesting concept and capability. So I think it's not important, but it's interesting to see the GitOps stars of those three projects, Terraform, Pulumi, and TerraGrant. Obviously, Terraform is the largest and most successful, but also interesting to see how Pulumi and TerraGrant both of them are very popular as well.
Absolutely. And I want to jump over. I see a couple of questions here that we have that came up. One of them says, initially, company prefer the cloud agnostic or multi-cloud tools, but then they end up with the same cloud for long term. So does it make sense to use that cloud to use the cloud specific tools? And I think it still makes sense to use the cloud agnostic or multi-cloud tools over those, even if you're going to be in that cloud for a while, because you don't necessarily know if you're going to be in that cloud for a while for sure. And I want to follow that up with, we have another one here that says, how likely is it that somebody would pick a different cloud to push their infrastructure to? And it's to them, it seems like an edge case, and it is. And this one kind of folds into that last question a little bit of, why might you need the portability? Just think of it, what happens if your company gets acquired for whatever reason, or a company gets acquired, that new company that's taking over is in a different cloud, and all of your stuff now has to go because that's where all their agreements are, et cetera, et cetera. So it may not necessarily be likely, but there are absolutely cases where entire companies that are 100% Azure shops or AWS shops or GCP shops, or even on-prem, are all of a sudden told, hey, all of your stuff has to go over here. You have 12 months to do it or else. When I was back in, sales wings and stuff like that, I saw it. I helped companies who had to go through that kind of transition. So it's definitely a thing. And that's one of the reasons why choosing the multi-cloud framework may not necessarily, mean anything right now. It's just kind of an insurance policy or a what if to help you with a possible transition later. So, there's lots of different variables and things that might go into that. So that's just something that I saw pop up that I wanted to kind of fold into that conversation there. So with that, we talked about all the different frameworks a little bit, kind of some of the pros and cons, why you might choose one over the other. Specifically moving through to the pitfalls of infrastructure as code, and some of the things that you might run into. One of them that we talked about a second ago was just choosing the right framework. That's a big one. But one of the biggest questions that I get is like, what kind of problems can you come across with infrastructure as code? And unfortunately, the answer is a lot. And it's because not only do you get all of the pitfalls that come along with, traditional infrastructure, you get a lot of the stuff that comes along with the problems of code. So you kind of have to work on both to kind of figure out, hey, I've got these types of problems that could be this, these types of problems that could be that. Ohad, in your experience, is that kind of what you've seen with infrastructure as code, like all the different kind of problems, things you have to think about and stuff like that when you're trying to, as a business, operationalize infrastructure as code?
Yeah, sure. I would just maybe start with the concept of drift. Okay, so when you have infrastructure as code, you often reach a situation that you have a drift. And for those of you who are not aware what a drift means in infrastructure as code, it means that the cloud is in one state and the cloud resources are in one state and your code is not fully aligned. And it's usually happens because you probably maybe still have people with direct access to the cloud account, and they sometimes not sure how to change the code, forget to change the code. They want to quickly change some cloud resource and they do not update the code. So they change something directly in the cloud account. And then it causes a drift, meaning that maybe the next code execution will revert the change that they did, which is extremely risky. But that's just one classic example of what are the pitfalls with infrastructure as code. You need to think about cloud credentials. Okay, who has access to the cloud? Basically, now a robot needs to access the cloud with code execution. So now it's not a question of who has access to the cloud, it's who has access to execute which code on which cloud account, under which circumstances. Okay, that's the new way to operate cloud when you move to infrastructure as code. You cannot just say, okay, I'm using code and that's it, because you're going to run into problems. And drift is the basic one. Role-based access is another one. Policies, budgets, everything is totally different when your cloud deployments are being done with code execution, and you need to be aware of that.
Right. So do you have any recommended tools for checking for drifts and sending notifications? This is a chat question that we had.
So I'm biased. So the first one I would recommend, I would recommend is env0, and maybe it's a good opportunity to explain what env0 is. env0 is this infrastructure as code management solution on top of your infrastructure as code. Maybe you've heard about Terraform Cloud. So env0 is a leading alternative for Terraform Cloud. We have some great features that Terraform Cloud doesn't have, and vice versa. So it's, if you're looking for something, beyond GitHub Actions or beyond Jenkins or Circle CI to manage your Terraform workflows for role-based access, policies, self-service, budgets, cost, notifications, integrations, approval workflows, all of that, you should check out Terraform Cloud by HashiCorp, but you should also check env0. And env0 specifically knows how to detect drifts and send you a notification whenever there is such a drift with an email, Slack, or Microsoft Teams notification. So that's one good, solution, a hosted solution that does that. There is an open source called Drift Control, driftctl, that helps with you to do that as well, but that's a CLI, so you need a system when to trigger that, what kind of notification to get when you identify drift, what happens if there are deployments pending while there is a drift. So drift control is a good piece. It's a good open source to attack that, but it's not a full solution, but it's for sure super helpful to identify if a drift exists and also what exactly the drift is. So I would recommend, if you are worried about drift, check out env0, check out driftctl, and reduce the chances of having a drift.
And that is definitely a big problem. I mean, once you start automating these things, you start putting your code files into a repository that becomes your single source of truth. You really need to restrict who's able to go out there and manually make those changes, because those changes should be made, the actual way, by doing a pull request on the main branch, going through, making your updates, making sure that works, merging it back and re-updating. So, it's just one of those things where the methodology that you choose, the accesses that you give, is definitely something that can cause problems. You need to make sure that you're keeping an eye on all that kind of stuff. If we look to the other side of some of the issues you can have with infrastructure as code, we had the infrastructure, but then there's the code side. A big one that I see is generally going to be code design. And with that, do you break it up into little pieces? Do you have one giant application which has a giant state file? The big mitigation for a lot of the code issues is going to be using the dry methodology, or the don't repeat yourself methodology for programming. There's lots of different ways that you can utilize this. Using infrastructure as code, you can put all of the different resources that you have into one giant file and run it, and it will deploy everything all at one time. But at that point in time, if you need to update one little thing in there, it's going to go through and it's going to rerun the whole thing. Well, if you use a don't repeat yourself methodology, you can kind of break that up into a little more manageable pieces, so that you don't have to go through and rerun the whole thing. You can just rerun, say, the networking module or the storage module, and kind of piece those together in ways that if you need to make an update to one, then you don't have to go through and update all of the other ones. Another big one is actually, how many copies of the code are you going to have? If, say, you have production, you have your development labs, you have staging, you may have a QA environment, you're going to have a bunch of different versions of the same application. Well, with that, if you design it in such a way where you don't hard code certain values like IP addresses and server names and things like that, then you're able to reuse that code and just go through and kind of, deploy it out with certain, things changed. Ohad, what are some of the tools or some of the ways that you can, reduce the amount of code that you have to manage and maintain and stuff like that with infrastructure as code?
So the first thing is to smartly use variables, obviously. Okay, by the way, like in basic programming, when you learn how to program, I think one of the first things that you learn is not to use hard-coded values and to use variables. And so that's the most important thing. Maybe variables files, in a reference that contains more than one variable for an environment. It's also important, if you decide to decouple and to separate compute from storage, from network, and it reduces, those state files now become smaller and faster. The execution becomes faster, and it's easier for teams to work on one thing without locks. But there are dependencies. Okay, so be aware of dependencies, and you need to have a workflow. Okay, so if you manually execute Terraform apply or something like that on your laptop, do not forget to execute Terraform apply in the right order of the things that have dependencies. If you use Jenkins or other CI, Circle CI, GitHub Actions, don't forget to implement that. And if you use something like M0 or Terraform Cloud, don't forget to define those dependencies in the UI or in the Terraform provider, and then you can sleep without being worried that those deployments will cause any harm. But it's important to pay attention to it. There's no right and wrong answers, but you need to understand what you're doing, why are you doing that, what's the rationale, and what you need to make sure to reduce human errors.
Exactly right. And that kind of leads us into a question that we've got over here. Let's say we use dry concept. We may end up with having to run everything individually. Example, to create a new Kubernetes cluster, we may have to run 10 different Terraform modules. So if we want to make it easy, should we link it all up in a pipeline or an app or something like that while still using dry? And that's kind of what you said, making sure that you have those interdependencies mapped. You kind of know every time I re-execute module A, I then have to go execute module B, C, and D so that they subsequently get their updates and what have you. So definitely using some kind of pipelining tool or some kind of other deployment tool. Obviously, again, we're biased to ours because our deployment tool is specifically purpose built for infrastructure as code, and we have the ability to go through and do workflow triggers. So if you have those 10 modules, you can either call them individually, or you can go through and say this one is interdependent to that one, and then that one and that one. So every time that there is a successful deploy on A, it'll deploy B, and then C, and then D. So it definitely helps if you have the automation in place to kind of string all these together. And another thing that we touched on for half a second there is making sure all the different groups and stuff are involved. There's a thing here that says, what's your experience with reviewing infrastructure as code with stakeholders, such as security teams that, might not be code literate, but are very interested in security group changes and stuff like this? This is another pitfall that I think is very, very important, is just because you're moving to a more developer-friendly model does not mean that the developers are taking everything and nobody else, from security or infrastructure or networking is still involved, because that's not the case. Security is still security. Networking is still networking. I think this is one of those scenarios where it helps foster that communication, where you definitely need to have everybody involved. Security should still be doing the security design. The actual implementation of that code, that should be done through the, through the developers who are writing the actual code. But security should be the ones that are actually going through and saying, yes, you need to do this or do it this way. You can always implement some kind of, procedure where if there is a pull request to make some security updates, somebody from the security team has to be briefed on what it is, and they have to approve that before it's actually merged and deployed out, for the change. So it definitely, you still need all those stakeholders involved, and it can actually help you be more successful if they are more closely involved in the loop for, making these files, building it out, making updates and stuff like that. Do you agree, Ohad?
I couldn't agree more, but I have to add policy as code. Okay, when you want to ensure compliance, security, and basically any kind of policy, okay, and you can do it manually. You can have procedures, you can have papers of what needs to be approved when, but if you want to do it in scale and reduce human errors, you want to automate that process. And luckily we have great policy as code mechanisms, engines like OPA, Open Policy Agent, and also there are some great static code analysis tools like Checkov or TFSec that they will just automatically go over your, for example, Terraform code. And if you try to provision a new virtual machine, let's say a new EC2 instance, but the password for the root is weak, okay, it will automatically prevent that from you. So the security team can just, enforce that you will execute those policies, you will execute those great open sources, and you cannot trick the system. Okay, if they set the policy, they can, understand, they can realize that nothing bad is going to happen. And also maybe in production, some manual approved workflows for some specific things that still need some, different kind of attention for the most sensitive kind of deployments. But the vast majority can and should be fixed with automation, like policy as code and static code analysis automation.
Exactly right. And we have a question over here of like, how do we manage different environments in Terraform without a Terraform cloud or an M0, say S3? So this is one of those questions that we get a lot, and it's actually all of the Tacos platforms or Terraform automation and collaboration softwares, which is M0, Scalar, Spacelift, and Terraform Cloud. All of these solve that exact problem. With infrastructure as code, when you're just starting out and it's like one person on a team that's doing it with a laptop, it's cool. They kind of have an idea of what's deployed. They have all the state files. They can kind of see what's going on. Once you start to scale that, that's really where the visibility and tracking issues come in. It's hard to tell who deployed what, where it is, what variables they used. All of these kind of visibility issues, specifically like how do you manage all those different environments, that's the exact problem that we solve, either us or Terraform Cloud or one of the others. So to me, it's very difficult to be able to manage all of that. I mean, I would just take an Excel spreadsheet and say, this is deployed and this is deployed and this is deployed, or some kind of, just notepad. Other than that, if you have a, Terraform automation and collaboration platform, it's a lot easier to just click in and say, oh, in production, I have these 5 things deployed. In, my ephemeral development environments, I have these 50 things deployed. You can go and see who's working on it, how long it's been there, how much it's costing. So if you are trying to manage a lot of different Terraform environments, you're trying to manage it at scale or across a team, using a dedicated platform for something like that is going to save you a lot of headaches down the road.
I have to say the exact same thing, but let's talk about a different problem with Git. Okay, so let's imagine Git without GitHub or Git without Bitbucket and GitLab. Okay, so if you are one developer, maybe you can just use the CLI of Git. Okay, you do Git clone, then some Git commit, and eventually some Git push. If you're one developer, you have one Git repo, 10 files, I don't know, it still makes sense. But then you have 10 and 50 and 100 developers, and you have different Git repos, and you want some people to have access to one Git repo, but no access to the other Git repo. Maybe read access to one and write access to the other. And then you want to make changes in a way that scale, and you want that concept of pull request, right? Because somebody suggests a change and somebody else needs to approve it, and there are maybe some unit tests that need to be executed, and you need to have some coverage. Git doesn't solve that. Git is just, you want to change the file, you want to execute, you want to change code, you want to push it, that's it. But when you have bigger scale, more developers, more changes, more things to manage, that's when you need a dedicated solution. And I think the same answer goes here. If you have one workspace, one developer working on Terraform, that's not a problem. Just use Terraform init, plan, apply, destroy, and even execute it locally, as long as the state file has a backup. That might be a good enough solution. If you're starting to have a couple of more developers, maybe use Jenkins. If you start having more, we still didn't mention the name Atlantis. Atlantis is a great open source that helps you solve some of the GitOps related requirements for infrastructure as code workflows. But if you have dozens of workspaces, 5 or more developers, you want to empower self-service, you want to understand the cost implications. Basically, you want to make sure that the workflows work as expected. You need to have a dedicated tool. That's the entire goal of that tool. And as Tim mentioned, We are aware of 4 such great solutions: Terraform Cloud, N0, Scalar, and Spacelift. So check out all 4 of us, and I'm sure you'll find the best tool out of those 4 to help you with managing when you need that scale.
And there, a shout out to Eric Osterman in the SweetOps group. There is an awesome video out there on YouTube that is of a recording of the SweetOps DevOps office hours that they did. And it was an hour presentation where all 4 of us got on. Ohad did a 10-minute of us and all the other platforms out there. So it's a really good chance to kind of see all of us get together and, you know, show the differences in each one of our platforms and kind of what the other ones are doing and stuff like that. So definitely check that out if that's something you're interested in seeing the differences on. You kind of talked, you said my trigger word there for a second, and this will kind of move us on into the last little section that we're kind of getting here, use cases. You said the word GetOps. This word to me is something that I feel gets horribly overused because people just say, oh, I have a Git repo and I'm doing infrastructure as code. I'm doing GetOps. And that's just not the case. GetOps is a very, very specific term that was coined by Weaveworks. And if you really just boil it down as far as you can, it is infrastructure updates by pull request. This is something that is like our pinnacle use case. It is kind of the promised land, so to speak, of, you know, infrastructure as code use cases and methodologies. And I think it's where a lot of people would like to be. Ohad, break down GitOps and kind of that methodology a little bit for us, and maybe some of the things that you can do to kind of start working towards that direction.
Yeah, sure. So when you use infrastructure as code, everything starts at the Git repo. Okay, every change starts at the Git repo. And if you don't do crazy things and just push to your main branch, you obviously first start with pull requests. And so you can look at a pull request the basic way and just look at the difference between the previous files and the new files. And then your colleague needs to make a decision whether or not to approve that change. But reminding you, it's not that Java code or Python code or a Node.js code. It's not applicative code. It's the infrastructure code. So it's more dangerous to change that. Just reminding you what it means 20 years ago when you had the room of servers. Okay, so
Yeah.
this now pull request is equal to saying, okay, I'm going to destroy those 5 HP servers and I'm going to purchase those 10 new Dell servers with a different operating system. And you do that with maybe one single line of code change now. Okay, so maybe it's not that clear when you do that change. What are the implications of that change? By the way, sometimes you even have a syntax error in that code, and maybe the new code cannot be executed at all. So with good GitOps processes, it means that you want to ensure that your pull request have the right capabilities for your colleague to make a smart decision when your colleague needs to approve it. So you need to, for example, execute, if it's Terraform, you want to execute Terraform plan, like a dry run, of what's going to happen on all of the affected workspaces. Maybe there is more than one workspace that is going to be updated, maybe more than one cloud account that is going to be updated. Maybe you need to execute some policies. Okay, maybe this code should never be executed and it should fail the pull request and you should not be able to merge. Okay, if it's too dangerous, if it didn't pass the security policy or the open policy agent policy, if it's too expensive. Okay, maybe the change that you're going to do is going to create dramatic increase in your monthly bill. And then you're going to face that famous cloud bill shock. So we want to shift left all of those and allow your colleagues and yourselves to make smart decisions when you actually develop that code before you merge and push.
Awesome.
that's
So
the
everybody on their bingo cards, if you had shift left for your buzzword bingo, you can go ahead and mark that one off. That was one we were looking for. That's brilliant. Awesome.
Another thing in GitOps, in the concept of infrastructure as code, was okay, you
Mhm.
made all the right decisions and processes in the pull request. Now you're ready to merge that pull request. You don't want to create a drift, because if you updated the code but you still didn't execute it, that's another drift. So you want to reduce that time to something very minimal, or basically immediately execute that code. But maybe another person is now executing something, or maybe there is a new provider version that is being released from the time you executed the plan on the pull request till the time that you're now trying to merge that code, and your code is automatically using the latest version of such a provider. So it's not that trivial that you just execute the changes that happen when you approve the pull request. You need to understand if something new happened to the cloud resources, if something new happened to the modules and providers that you depend on. So you need to also automate that process and make sure that all of the policies, all of the workflows happen, especially after the merge, and not just in the pull request, because that's where the actual changes happen.
Right. So it sounds like the moral of the story there is the more checks and tests and things like that that you can do at every step of the process can help save you a headache down the line. It may add a little bit of time to, to the pipeline or to the workflow, but really overall, what's it, stopping you at step 2 instead of getting all the way through step 10 just to find out that you have to go all the way back. So making sure that you kind of making sure that you close those feedback loops and fail faster, that overall is going to help you be more successful in infrastructure as code and in DevOps and, all the other cool, stuff that you've got going on. It looks like we've run out of little talking points here on my notepad, which is great. It was awesome talking to you. I want to make sure that we give some of the people here a little bit of time back and find out, who won the gift cards and stuff like that. Any closing thoughts or anything like that, Ohad?
No, I really enjoyed the conversation. I do encourage everybody here to follow me on Twitter at DevOps Ohad, and also check out M0 at www.m0.com to better manage your infrastructure as code.
All right,
Excellent.
Great. We actually do have a couple questions that are still sitting out there. If you guys want to try to address them real quick before we move on to the gift card drawing.
Ohad, is there any TDD concept for infrastructure as code?
To write a test before you write the actual code. I think there is. I've seen a few people that do that, but honestly, I don't think it's that common. Because you have the concept of plan. Okay, because you have the concept of plan, you can actually execute those automatically in that process. So
Right.
Again, I think it's too early in the journey. By the way, I think a lot of best practices will emerge in the next few years. A lot about architecture and how much to decouple, what is the best practice there, big state files versus a lot of smaller state files. And I think the testing and coverage concepts of infrastructure as code are also something that is transitioning as we speak.
Right. And another one here that we got is, do we recommend the GetOps methodology based on all of the complexities that we just mentioned? And I would answer that with yes. Now it definitely can be kind of a daunting task to, go from nothing all the way into a full GetOps methodology. I would definitely say that it's going to be a baby steps kind of thing. You're going to take one step further, then you're going to take one process that you may be putting at the end, and you're going to shift it left closer into the deployments. Then you're going to take the next one and move it in. You may do some tinkering here and there. There's definitely not kind of a one-stop shop tool that you can just dump in there and make it work. There's some companies that are going to tell you that they could probably do that. But like all of the different testing and the full methodology, I mean, it's going to be something that you're going to have to work at and build. But I absolutely think that that's one of the greatest methodologies. If you are using infrastructure as code, it's going to make your life a lot easier in the end. The more of those tests that you can shift left and bring closer into the deployment processes. I got another one of what was the YouTube comparison of the various vendors you mentioned. So this is going to be the SuiteOps office hours. And actually, Ohad, if you want to talk for half a second, I will put that link in the chat or answer that question for them with the YouTube link. Because that's a really good one, and I like to give it to everybody.
It's a really good one. I do have to say that it's from December. Okay, so it's now 8 months old, and a lot of great capabilities in all 4 vendors are not presented there.
That's true.
So I think it's a good start, to understand all of those 4 solutions. And the category name starts to feel like the name is tacos, Terraform automation and collaboration software. So it's a great start for you to compare. I honestly believe all 4 solutions are much better than in-house solutions, CI, Circle CI, Jenkins, GitHub Actions for that purpose. We do not replace Jenkins. All of those tools do not replace CI. That's how you build your Docker images. That's how you, build your images. But when it goes to workflows of infrastructure as code deployments, that's probably where you need to look at those 4 solutions and also look at the updated website and content of all 4 vendors to make a smart decision. And for us at M0, always feel free to reach out to us by scheduling a demo or contacting us on the chat if you want to hear more updated information.
All right, great. So I could real quick, I guess, Tim, you did put it in there? Yeah, okay,
yes,
all right.
I put the link to that YouTube video right in the chat.
So yeah, all right, perfect, great. So with that, then I will just say that if anybody has any last minute questions they want to go ahead and put into the question and answer period, we might not get to them, but please know that these fine folks will be getting a copy of all of the questions that came in, and I'm sure whatever did not get answered during the webinar will be answered offline. So please feel free to continue to use that question and answer tab to get in any last minute questions you have. Another quick reminder that today's event has been recorded, so if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. We will be sending out an email that contains a link to access the webinar on demand. And we are also going to have the webinar on demand on devops.com. So you can always go look for it there. Just go to devops.com/webinars and look in the on-demand section. It should be right there waiting for you. Okay, real quick, before we close things out, let's do the drawing for the 4 $25 Amazon gift cards. Right. Our first winner today is, drum roll please, let's see, Elvis M. Congratulations, Elvis. Our second winner today is Nestor F. Congratulations, Nestor. Our third winner today is Todd F. Congratulations, Todd. And our fourth and final winner today is Prince M. Congratulations, Prince. All right, so we'll be following up with all 4 of you via email to get your Amazon gift card over to you. So please check your inbox. And if you don't see it there, please check your spam folder. Tim and Ohad, thank you both. What a great conversation, and so many questions that came in. That just proves that it was a very relevant conversation. So thank you both for your time and your expertise. I appreciated it. The audience appreciated it. And everybody's seen it. Seems like it was 49 minutes very well spent. So thank you both. I appreciate it.
Excellent. Thank you for the opportunity. Thank you very much.
All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.